We're recording. Okay. Again, yeah, I think it was like plug and chug type math, as long as you understood where everything needed to go.
Yeah.
And what you were looking for. So I'm okay with starting the quiz.
Yeah, me too.
Let's do it.
Okay.
You dye your hair, Haley?
More like bleach the crap out of it, but yeah.
Okay. Group quiz.
So do you want to do 6 and 7 right now?
I thought that was the plan, but I'm okay if you guys have finished it.
Yeah, I'm totally cool with that. I just wanted to confirm it.
Yeah, I'm fine with it. I don't know about Keith.
I'm good.
All right, let's do it then.
Okay. Perfect. Okay, so first question. Oh my God, we completed it. Yeah. Okay, so question number 3. It says when you're taking a sample size of 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Oh,
so,
I'm sorry. Go ahead.
Oh, I was gonna say this is Q right. Yeah. Or
yeah, because it's a small sample size.
Yeah. Do you agree, Haley?
If it's a small sample size, it'll be the same as the parent population.
Yeah. So it'll be.
If I understood it correctly.
Mm-hmm. Yeah. In order to be normal, has to be a large sample.
Right.
So
question. A sample size of 100. What is the shape of the distribution?
So that will be normal.
Hey guys, I'm gonna try to go through my phone and talking on my phone and doing like stuff on my phone at the same time with the quiz. So if I cut in and out, then I'm not gone. I'm just trying to do stuff on I do the quiz on my phone as well. So let you guys know.
Don't worry about it. Question number 5. It says, when you're taking a sample size of 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? So it will be normal too. Yeah, do we agree? Do we all agree? Okay, perfect. Question number 6. When you're taking a sample size of 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? Normal. What you know? Okay. Who wants to go for question 7?
That was Monday.
Okay, so when the distribution of means is normally distributed, choose all the correct responses. Data are drawn from a population that is normally distributed.
No, that's false.
Yeah. Yeah, that's fine.
It's 1, 2, and 4.
Not too loud.
Wait, what do you say, Keith?
1, 2, and 4.
How are we doing on the quiz so far?
I don't think. Wait. Oh yeah, that's true. 1, 2, and 4. Wait, 1, 2, and 4, right? Let me see.
Yeah.
Oh yeah.
Okay.
Yeah, you got it.
Perfect. 1, 2, and 4. Okay. Okay. Question number 8 says, which of the following gives the best explanation for central limit theorem? Is that C? I believe. I think that was on the quiz too.
That's a C. Yeah. The sample size, the shape, distribution, sample means.
Quick question on number 3, guys. Is it skewed to the left?
No, right.
Oh. Well, it's skewed to the right.
Yeah, it's the same as the parent population.
Oh, gotcha. Okay.
So number 8 is C, right? Do you agree with that?
Yeah.
Okay, perfect. You want to read next one, Haley?
Yeah. Use the following information to answer the next four questions. Let X be a random variable with population equaling 10.
Are 3 and 4 the same question?
Or 3 and no, they're different.
How are they different? They look the same to me.
Because you have a large population.
If you read it, they're different.
So they both rightly skewed then?
No.
No.
Question four is normal.
Oh, question 4 is normal? Oh, because their
Yeah,
sample
because-
size. Oh, I see. Because their sample size is different.
It's large, yeah.
And population standard deviation equaling 6. Suppose the sample size n is 36 is drawn from this population. What is the mean of the distribution of samples?
So it will be the same, right?
10, yeah.
Yeah, 10.
Are we on question 5 or 6?
Around 9.
Oh, 9. Holy crap.
Okay, so explain to me why it's 10, because I didn't understand this one.
So in the material, it says that the population, that the sample mean is going to be the same of the population mean. What it changes is the standard deviation. So let's say the standard deviation is going to be less than the standard deviation from the population. Like, I don't specifically know why, but it's just how I read it was. The population mean is the same as the sample population. The sample mean, sorry.
Okay. Okay.
Does that make sense?
Yes.
Oh, yeah. Testimony bingo?
Okay, so question 10, it says, what is the standard deviation of the distribution of sample mean? So in this case,
No.
close to sample, it will be 10. No, wait. What is the standard deviation? It's 6, right?
Yeah.
So it will be 6 over the
Square
square
root
root of 36. So it will be 1.
Yeah. Wouldn't it?
Yeah.
6 divided
Yeah. So
One.
you got, yeah, 1. Perfect.
by, regardless of the distribution of the population, if the sample size is large, would be, let's see, what would be the shape distribution of the
Be normal.
What is it?
30?
Normal.
Normal, right?
Yeah.
Haley,
Yeah.
can you guys hear me well? I hear a lot of background noise. I still
Yeah.
hear a lot.
Noise and like talking.
Yeah. Matt, can you mute your microphone?
What?
Can you mute your microphone?
Yeah, hold on.
Yeah, because I
Sorry,
think you'll be
guys.
able to text.
You're fine.
Okay, that's way better.
Yeah.
Okay.
Okay.
So Matthew, if you're listening, if you want to talk or say anything, just text, like send a message or whatever.
Yeah.
Okay. So number 12, right? What theorem would justify respond to the last question, and that is law of large numbers.
Central theorem.
Oh, really? Oh, yeah, it's true. The sample
This
size. Yeah, you're right.
Distribution of, oh, yeah, okay. Okay.
Yeah, you're right.
Okay.
Yeah, the law of large numbers is when
You get close, more accurate because you've sampled more, right?
yeah, it's gonna be close to the population mean.
Well, we missed one,
We did.
or at least I missed one.
I got 100.
Which one do you miss, Haley?
On 8. If I thought we said C on 8.
Yeah, that's what we said.
I
What is
said
it?
My C is if the sample size is large, the sample mean X, whatever, will be close to the population mean. Is that what you guys have?
no. The answer is if the sample size is large, the shape of the distribution of the sample means will be approximately normal.
Oh, okay. That's D on mine.
I tried reading it. I couldn't hear a darn thing though before, so
Oh, okay.
I thought we
Yeah,
all
me
had.
neither.
Right. Okay. Well, that's okay. I'll fix it later. Okay. So quiz 7.
Okay.
Do we have to do 2 separate videos?
Now,
I can post the same
One for each.
and just tell them to start at a different time
yeah, we could do
Okay.
that.
and see if that works for them. If not, I can make 2 separate videos next time.
Okay, so what, lesson 7, I'm on it. I'm on it.
Okay.
All right. I'm opening it.
7 was a lot of review from 5 and 6.
Yeah. Wasn't bad at all. There's a lot of calculation. A lot of math.
Yeah. Okay.
That sounds to me that you already took the quiz, Haley.
I haven't this time. The first one I did, and I was like, I don't know why I'm wrong on this. And then no, I haven't taken 7 yet.
Okay. Good. Okay, so there's 12 questions here.
Yeah.
All right.
Question 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places.
So the area in between those, right?
Yeah, I got 0.175.
You got what?
0.175.
Hang on.
Well, I'm getting 0.8255 for the area in between the two C scores.
Oh yeah, no, I'm getting on the normal probability applet, I'm getting 0.175 once you round.
Yeah.
Yeah.
Now the combined area, I'm gonna send it okay. Oh, to the right and to the left. Oh,
In
my
between.
bad. Okay, so it's 1.175, right?
Mm-hmm.
Okay, good. Yeah, I was reading. I thought it was in between the two of
Oh,
them.
that's okay. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations X. This cannot be determined. Oh, smaller standard deviation. Is it B?
I think so.
Yeah.
I think it's B. I'm really
Yeah,
not
because
about that
you
answer,
have
so
to-
someone
because
can
you,
like.
you have to do the square root. Because the sample, what is it? The standard deviation of the sample population is always way smaller than the standard deviation from the population. But I don't understand A though.
The distribution of the individual observations. Oh, that's how many not samples, how many data sets you have, right?
Mhm.
Like
Or what?
like if you surveyed 36 people, then you have individual observations would be 36. That's how many, right?
I think so, yeah.
I think that I'm not sure. I mean, don't quote me on this, but I think the individual ones would be if you did it without a sample size, just an individual. So you know, like how we divide by the sample size, like the
Mhm.
square root of that. I think it's without that.
So do you think it's B2?
I think it's B.
Yeah?
Yeah.
Okay. Move on.
Which of the following?
Question.
Oh, go ahead, Cal.
Okay. Which of the following results imply that the square in x decreases, size increases? The normal distribution, the 6895, the 9.7 rule, the central limit theorem, the law of large numbers.
Law.
The law of large numbers.
Yep.
Okay. So scores on a quantitative portion of the GRE are approximately normally distributed with mean of a 150.8 and a standard deviation of 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score depending on Diane's score?
It will be 160 minus 180.8 over 8.8.
Yeah. 1.045.
1.045, yeah.
Okay. So, and that's with,
And if we,
I'm trying to
we-
remember that equation. What's the equation again?
It's the
oh, go ahead, Keith.
observed number minus the mean divided by the standard deviation.
Okay.
That gets you a z-score.
So it'd be 160 minus 150.8 divided by 8.8.
Yeah.
Yep.
Okay, got it. 7, do you want to read it, Camilla?
What is the probability that a randomly selected student will score above 160 on the quantity portion of the GRE? So for that, we can use the C-score that we just got. We'll just plug it in the normal probability applet, right?
Yeah.
And above that, I'm getting 0.148. Is what I'm getting. What do you say, Haley?
I'm sorry, I'm just putting it in right now.
Okay.
$0.148, you said?
148, yeah.
Awesome. Okay. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these student scores?
So do we get the mean out of the scores first, right?
Yeah. So
I'm gonna-
you add them all up and divide them by 5. That'll be your
The 5, right?
your observed value. Then you subtract it from that
150.
mean again, right? 150.8.
Yeah. And then divide it by 8.8. Right?
Yes, I believe so.
Yeah, I agree.
5.
So I got 160 too. I got 160 as the mean. What do
Yeah.
you guys got?
Yeah.
Is that the mean from those 5 scores, right?
Yep.
So 160 minus
will be-
150.8.
We just
Divided
did
by-
that.
It'll be the same z-scores before, but then we're going to have to do the 5.
Have to do the what?
So we got the 5 different students. So we'll have to divide it by the sample. So we'll divide it by the 8.8 like before, and that 8.8 will be a different standard deviation, which is also divided by
Oh, we have to.
the sample of the square root of 5.
Yeah, you're right.
Oh,
Oh, I forgot that.
Okay.
Thank you, Keith.
I do not have a complex enough calculator to do that at the moment, so you're gonna have to tell me what you get.
I got, after rounding, I got 2.338.
2.338. Yeah, same.
Okay. So just to ask you, Keith, how did you know that that was one of my biggest issues? Is I don't know when to use that, like the square root of the sample size. I don't know when to use that or not.
So when it's asking for a z-score,
Yeah.
and it gives you a standard deviation, a mean, and a sample,
Yeah.
to use the sample. Does that make sense?
Okay. So if it's not in there, don't worry about it.
Yeah, if they don't give you, or like in this case, we had 5 samples we could see.
Yeah.
Mm-hmm. Or when they ask you, also Haley, when they ask you, they give you a specific mean and a standard deviation, and then they ask you how from this population, let's say that you graph 20 students, what is the probability that 20 students are gonna get a mean that is 10 points below the actual no, an average that is 10 points below the mean.
Okay.
You have to do the same, but instead you type in 20 students as a sample,
Okay.
and that gives you a standard a c-score, and then the c-score you plug it in the normal probability applet, you can get a probability.
Oh. Okay. All right. 9. Anyone want to read it? Okay. Go for it.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answer to 4 decimal places.
So don't we just need to put in our
The
z-score?
z-score?
Yeah, and then
I
select
think
above
so.
that.
Yeah, and
Yeah.
then select higher than that, right?
hmm
Okay.
So I got 0.0097.
Same. 0.0097.
Okay, that's what I got.
So wait.
But it wants
Oh.
it to the 3rd decimal place, right? So it'd be
No,
4th.
4th. Oh, sorry, I didn't read it all the way through. Okay,
Yeah,
got it.
yeah, I thought the same. 0.0097.
Okay. Suppose the mean GPA of BYUI students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected?
Normal.
Normal.
Because there's 81 of them.
Yeah.
Yeah, it's large.
Okay.
Next question, it says, what is the mean of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population?
It'd be the 3.5 again.
Yeah.
Because that's the mean of the mean, right?
Yep.
Okay.
It's the same name, yeah.
12. What is the standard deviation of the distribution of the sample means for all possible sample sizes of 81 that could be drawn from the population?
It will be 0.7 over the square root of 81, right?
Yep.
So it will be
Wait,
0.7
Why,
over
hold on.
9.
Why would it be that?
Because you have to get
Because,
your new standard
go ahead.
deviation.
Say that again.
Because you have to get your new standard deviation for the sample size.
Okay.
Because that's what
Yeah.
changes. The mean stays the same, but the standard deviation changes.
yeah, so the formula for the standard deviation of the sample,
hmm
the standard deviation of the population over the square root of the sample, of how many people you get in the sample.
I see.
In this
So it's
case,
saying what's the standard deviation of the 81 students, not the whole parent population.
exactly.
Okay, got it.
So it will be 0.7 over the square root of 81, which is 9,
Okay,
and that will be 0.07777, right?
0.078 is what I got.
yeah, because once you
Point
round,
zero.
right?
Yeah.
Yeah, I was just joking. 0.078. Okay, perfect. 0.078, right?
Yep.
Hey, round your answer to 3 decimal places. So wouldn't it be 778? Sorry, right?
778. No, it's 0.078. It's just 17 and 18 because you run it to 3 decimal places, so it's 0.78.
Okay.
Next question. It says, what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So in order to do that, we find the C-score for that first, right?
Yeah, because then you could put it in the applet, right?
Yeah. So it will be 3.3 minus 3.5, 0.7 square root of 81. The C-score.
And again, we're doing the square root because it's not the parent population; it's only the
It's a
81.
Yeah.
Okay, just making sure that I have that straight.
No, don't worry about it. So for the C-score, I got minus 2.571.
Minus 2,571.
Minus 2.571. Do you get the same, Keith?
Yeah. Sorry, I had already closed out of mine. I got 0.005 total. Let me try that again. Let me make sure I get the same Z-score.
Oh, wait, let me see. So the question is asking above. Do you say 0.0101?
0.005.
Yeah, because you're doing it less than that.
Yeah.
I'm doing it less than that. I'm not doing that. I'm getting 0.0101.
That's because you have
Oh.
the other side highlighted. You want the lower half. You want
You're right.
yeah.
I didn't see it because it's so tiny. I didn't
I
see it was
know.
highlighted. I was like, that's not.
That can't be
Point,
right.
so it's point.
Okay. What is the probability that the mean GPA for 81 randomly selected BYUI students will be greater than 3.3? So now it's just the other side, right?
Yeah.
Yeah.
Which will be very close to 1. Should be.
Uh-huh. It's going to be 0.9949.
Yeah.
We're going to 3 places. Okay, so 0.995.
0.995, yeah.
Okay.
Hey guys, so in the question number 13, the answer was 0.005, right?
Yeah.
There's only 3 decimal places.
Yeah.
Okay.
Okay. And I don't. Does anyone want to read 15?
I'll do it.
You can do it.
Go for
Go. You can go. Steve.
All right.
it.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean. So we're going to do both ends of
Well, I
the
got
bell
lost.
curve, but not the middle.
Right.
Okay.
So wait, what do we do? I got a little lost.
Okay, so
What we
let's
need,
see.
don't we need to find a z-score, and then once we do that,
Yeah.
we can plug it in and highlight the two opposite ends, right?
Yeah. So on this one, if I'm right, so when it says the sample mean was determined to be 177, that's where we'll start. So 177.6 minus the 185, because it's the observed value.
Right.
Oh, right. Yeah, because that's the mean from the sample, right?
Yeah.
So 77.5 minus 185 over 26.7 over the square root of 48.
Yep.
Yeah.
Yep.
And that gave me a z-score of minus 1.920.
Yep. Negative 1.920.
Yeah. So we plug that in first.
So
Um,
so
Yep.
the two extremes would be 0.101, 0.0101. Is that right? Once you highlight the
Wait.
two ends.
What is it?
I got 0.055.
I
For
got 0.0552.
okay, what was the z-score you got?
Negative 1.
Minus
Go for it.
negative 1.920.
Yeah.
Oh, okay.
So then you plug in both, and then you just highlight both ends, right?
Yeah.
Yeah.
So what is the question again? Question is, find out whether an example of passengers will have a rate that is extreme or more extreme. Yeah. And it's round to the decimal places, so it will be 0.055. Yeah.
Yeah. Okay. Got it.
For 5.5%.
So 0.055. Yeah.
0.055. Yeah.
Okay. Let's
All right.
see how we did. Yay! 100%. Okay.
We're the best group.
I know. It's because we have Keith. No.
Not really.
Okay. Cool. Well, I will post this to both, and then I'll just put a timestamp for when we started lesson 7.
Okay.
Does that
So
work?
good that we just finished everything for a week. I think next week we have an exam actually.
Yeah, we do. We have one group meeting and then the exam.
Yeah.
Awesome.
I think it's gonna be too hard.
Next Tuesday at 8:30 again. Yeah.
Yeah.
Yeah, sounds good to me.
Okay.
Haley,
Yeah.
I think we should try. I think we should try to, when we're skyping or when we're in the group meeting, to try not to be in a loud place, because it was really hard when Matthew was like driving with his friend, you know. And I remember reading about it when I was reading over the syllabus. It said something about like being thoughtful about your classmates, and so like everyone can enjoy, I guess, the group meeting, and it's not.
Yeah. Just
Everyone
everyone just needs to come prepared and be in as quiet a space as possible. Like at one point, my kids are like screaming back there. I was like,
Oh yeah, but that's fine. I mean,
but yeah, yeah. Everyone just needs to come prepared and try and not be noisy for everybody else. But
yeah. Okay, perfect.
Okay. Thanks, guys.
Okay.
Yep.
Bye.
Yeah.